Hello and good morning, ladies and gentlemen, and welcome to this special edition of Applied AI conference titled AI Meets Space. We at AI Austria and Applied AI conference are very happy to do this together with our collaboration partners from Brimatech and Space Hubs Network. And with me here on stage is Florian Lippok. Florian, what will we be seeing today? What kind of use cases and discussions have we prepared for our listeners and viewers?
Hello, good morning from my side. Good morning, Matthias. My name is Florian Lippok. I work for Brimatech. For those who don't know us yet, we are a market research and consulting company based in Vienna, focusing on technical innovation. And today, I'm also representing Space Hubs Network, which is a European acceleration program offering free mentorship for space startups in different stages. And what we also do is we organize events like this one in this project. And my colleague Susanne will talk about this in detail a little bit later on. And as Matthias mentioned, we are really, really happy to co-organize this event with AI Austria, represented by Matthias Grabner and Clemens Wasner, also Clemens will also have a keynote later on. Yeah, Matthias, do you want to explain a little bit the housekeeping today?
Of course, yeah. Well, it's already our, I think, eighth event in this Applied AI conference series. We started off with a general conference on sharing use cases and learnings on how to make AI work for companies and in organizations in 2018. And usually started off as a physical event. Can you still remember when there were physical events? It feels like a long time ago, and we've actually come a long way. Starting from last year, we moved to the cyberspace and offer these online virtual events, and quickly noticed that we can reach a lot of more people interested in AI applications. That's also why we decided to go deeper into certain sectors, for example, forestry, semiconductors, logistics, finance, and banking. And of course, a sector that throws off so many other technologies to other sectors in terms of tech transfer and broader applications is the space sector. Um, Today, we're going to look at how AI is applied in this also broad field of the space industry, so to say, upstream and downstream. And please bear in mind, this is all live. So we are sitting at our computers in our offices or in our homes. So do our speakers. This is not pre-recorded, which means that you will be able to interact with us live. So you are watching this on LinkedIn or on YouTube. If you have any questions, comments, remarks, something you want to know from the speakers or from us, please post your questions, get in touch with us. Also, if you are watching on LinkedIn, you can network with other participants of these events. Just check who is watching, and we hope we contribute to the community building of AI applications in the space field with this event. The question and answer session will be, we will pool all the questions we receive and ask them to the speakers at the end of each presentations. For the agenda, please check the agenda on LinkedIn or on the confirmation email that you received from Brimatech. Of course, this will be recorded, so if you miss anything, you can re-watch it. We will ask the speakers to share their slides, and if they agree, you will receive a version that we can share with you, but I'm certain that they will. Stay tuned. And now, Florian, let's get right into it with the program. Can you give an overview of the agenda?
Exactly. Let's have a quick look at the agenda. We have three blocks. The first block, in the first block, we see what the future might bring us in the area of AI in space. So this is represented in our keynotes, and we are really looking forward to this. In the second block, we will find out more about the funding opportunities in the space area, so how to accelerate this innovation. And the third block is reserved for networking. So we also want to offer the chance for you to mingle a little bit with other people who are participating today. And we're going to do this in the tool Wanda. And my colleague Stephanie will also explain this in detail a little bit later. But let's not waste too much time. Let's jump right into. Let's go to our first keynote. This is held by Riccardo Ducca from the ESA. Riccardo is a senior engineer at the European Space Agency at ESTEC since 12 years. He's part of the system team of the Earth observation missions LSTM and Truths for performance assessment, simulation, and data processing. Riccardo also manages several R&D projects related to data exploitation, machine learning, and blockchain. And the title of his presentation is called Artificial Intelligence in the ESA Space Projects. Riccardo, I'm really happy to welcome you. Hello, good morning.
Hi, good
Hi.
morning. Yeah, first of all, really thanks for inviting me in this event. I'm very glad. So,
We're happy you joined.
yes,
Please,
indeed.
the stage is yours.
Okay.
The stage is all yours. We have already received your slides and put it on,
Yes,
and we see
please.
each other for the Q&A session.
Okay.
And to all our participants, please feel free to post your questions to Riccardo during and after his presentation, and talk to you later.
Okay. Thanks. Thanks for inviting me in this event. I'm very glad to present to you what I'm really giving in this presentation. I would like to give you an overview of a European space project where we apply or we plan to apply artificial intelligence. I think Florian already make a small resume of my career. I'm working in ESA ESTEC in the establishment in Nordwijk, and I'm doing system engineering for Earth observation mission, and in parallel also managing some R&D activity with several novel technology like machine learning, blockchain, and cloud computing. In general, I have more than 15 years experience, both in ESTEC, but also in academia and in industry, and I've participated to development and launch of at least 5, let's see in the future, Earth observation mission. Maybe this slide will a little bit disappoint you, I hope not, but I'm very confident to say that ESA is not company like DeepMind, Facebook, and Google, that really they are leading the mathematical research of AI. We are more users. That means that we observe the technology, we make our trade-off, we make our analysis, and we see if there is potential to apply in our processes, in our application, in our design phases. We have a few technical objectives. I just report a few of them. Of course, we would like to embed AI machine learning in our hardware, in our software, both on ground and in space. We would like to use AI to speed up the development, design, and testing phase, and also minimize the costing associated to it. And also, of course, increase autonomy in robotics and in operation. And of course, boost all the applications that are built on top of space data. We have also strategic objectives. So we would like to engage, to make industry more keen to use AI. We are doing this with a lot of activities and a lot of line of funding, and also foster the collaboration between center of excellence and between expertise that are a little bit scattered in Europe. And also we exploit our engineering knowledge that we have internally in ESA matured through years of space launches. In this presentation, I will propose just few areas where we apply AI. There are many. I could collect all the information for my colleague, but I will speak mostly about the hardware and the software design, robotic operation and design, development and testing, and of course data exploitation. In my last 2 or 3 slides, I will report a couple of examples of projects with machine learning AI that I'm personally managing or our people in our section are doing. We start with the design phase, and of course, a big topic that we have in ESA is how to bring machine learning algorithm in space. What is happening now is pretty easy. We build a satellite, we launch, we test it, and then the satellite does its job and make measurement that are download on ground. We process them and then make available to the user to build their application. Now we think that the paradigm should be a little bit shifted, and we are planning to bring part of the processing and even the application in space. You see here an example of a motherboard with an Intel Movidius processor plugged in that hosts some algorithm of machine learning. Then this completely changed the game, because if we download less data, because the application is already execute in space at the moment that is acquired the data, then we can download less data. And this means the satellite has a smaller size, a smaller memory, less consumption of energy. And you see here an example of a small sat that I can hold really in my hand, developed by one of our industrial partner, Cosine. And some example of a result of one of the satellite, FISAT-1, that has on board an algorithm to cloud detection. So all the images that are fed by cloud that are useless are discarded, and even can perform some image detection. Of course, this offers a new challenge because it's completely different than developing an AI algorithm with normal data that you download in internet. There we have to deal with raw data on board of a satellite. So the training, the collection of training data set and the generalization of the algorithm is really a key element, other than all the qualification related to the hardware. The AI processor should be fully integrated in the platform and resistant to shocks and any other micro vibration. Even the validation is important, because if we download less data, we have less reference to check what is really doing. So we need a little bit to trust the machine in space. And of course, the definition of new quality metrics is really important. And also the operational concept should be completely revised, because this algorithm can be reconfigured in real time and on board. Then, speaking still in the design, but in the software, now the onboard software, that is the brain of our satellite. It governs all the mechanical part and the instrument and the electronics. Again, here we see a lot of possibility, both on ground, so in the development of this kind of software, so use machine learning to elaborate a requirement and then generate automatically as much as possible the code, and then also to bring autonomy on this kind of software to the satellite to be able to, for example, detect anomaly, to respond to anomaly, or to perform maneuver. And when we speak about autonomy, of course, our idea is this lander and rover, they go and they inspect the surface of Mars, of the moon, of the other planet. And here the autonomy is really brought to the maximum. And colleagues in the science and space exploration are really working to develop algorithms to make these rovers, this lander, more intelligent, be able to detect before the operator some of nominal situation, even to navigate situations that are a little bit more difficult without the support of the operator. Now we move on the operation, and here is the nice picture of one of my colleagues in ESOC. And I'm very glad to say that my colleague in operation were the first to see potential in the adoption of machine learning and AI in general. Because when we speak about operation, we speak about a lot of procedures that the operator need to do to inspect the telemetry and to make a correction maneuver in case of the nominal situation and also of nominal situation. Of course, this can be supported by the machine. The machine never sleeps, works 7 days a week, doesn't know bank holiday, can analyze a lot of data, never tired on working. And this can be really a support for the operator, for example, to check the health and the safety of a spacecraft, to manage some very of nominal situation. And especially this last point in this slide, monitoring the space traffic. There is a lot, we are launching a lot. ESA, NASA, the private initiative are really launching a lot. There is a lot of hardware up there, believe me. And then, of course, the orbits become very busy with active and inactive object. And then the monitoring of this traffic made also by the machine is really a key element for the future on this business. And here, unfortunately, the video doesn't start in the PDF on the top left, but believe me, it works. It's basically a computer vision application of the machine recognizing object acquired by the camera on a rover. So this is really important. The machine in real time can detect object and send an early warning to the operator, or even drive the rover somewhere else. So this is made really at an amazing speed, and it's very accurate. But when we speak about operation, we speak also about space safety and space control. And it's also important, for example, to monitoring the solar activity and the magnetic storm and any anomaly happening on the sun. And like here, I bring an example, or even in colleague on operation, to detect dangerous sunspot on the sun surface. We say that there's a lot of traffic there, and of course there is a lot of traffic also of the data downstairs. So all this constellation of satellite really required a lot of download, and the downloading capability is quite limited. It's linked to the availability of the ground station, and there are many, maybe not sufficient. So all this network of acquisition ground station should be dynamically reconfigured. For example, there is a ground station is of work for a few hours, then the other need to take over and still maintain the service, not to lose data. Or for example, there is a new ground station can be plugged for some times, temporarily or permanently, and then the acquisition network should be reconfigured to redistribute the load and the service that we provide in download to the satellites. And then colleague in operation, they are kicking off a lot of this project. This is one S-Track, to make the reconfigurability of the ground station very dynamic and very efficient. Now, a brief overview of what we do for testing, but it's more or less the same like in the operation. Testing is a lot of procedures, very long, very repetitive, I would say, very costly, and also very dangerous, like here, the firing of an engine. And again, colleagues in the test centers, in the test lab, are using tool of robotics, machine learning, to make this procedure more automatic, and even to support them on analysis of the result through all the computer science application and algorithms. Now we move in application, and the first is what is a little bit more familiar to me, is Earth observation. I'm not here to make a lesson what is an Earth observation. I just put a small, maybe inaccurate definition. Basically, Earth observation data can be defined everything that is measured in our planet, physical and chemical parameters. Of course, the first image that we have is the Google Earth. We open our mobile, we see our house from above, is an optical image, and this is Earth observation. It's not just like this. It's images acquired not by the optical sensor, but also from microwave sensor. But we can define Earth observation like any kind of other measurement, like, for example, the quality of the air, the atmospheric chemical parameters, the sea salinity, sea height, sea surface, sea current, and even the gravity profile of our planet, like in our mission Goshen. And in this slide, let me pass you, if I'm allowed, a small story, because when I start in my career, I start in Earth observation, and we had quite a lot of data. We were a bit a pioneer on this respect in early 2000, and of course, a lot of the information was extracted by the space data by photo interpretation. This was one of my previous work before joining HISA. But now, even if we have an army of photo interpreters, we cannot manage to analyze all the data, because so many satellites, so many data, so many different data, we can really build a lot of time series of these images. And then, of course, the machine help us to dig, at least to have a first screening of the information that is present in this kind of data set. And here I bring a few examples. The ship detection in left top corner in an harbor, or even monitoring of burn areas to assess damages, or even to assess how much carbon dioxide has been emitted to impact the atmosphere. As the most important on the right is for food security. That is really quite a topic now that we speak about Green Deal, optimization of the results. And then really to monitoring the agriculture, to monitoring the productivity of the fields. And here I'm bringing an example of an industry working with us that is monitoring the productivity of rice field in Asia. It is important because everybody needs food, but also we need to optimize water consumption, of the use of fertilizer, the user of a sustainable usage of the land. And of course, observation from space are global, really give an help on the what is so-called precision farming. This is not really Earth observation, but was a nice slide to put it. It's still observation, I will say. It is about the ERA mission, that is an asteroid catcher. The mission, in collaboration with NASA, will catch the asteroid together with 2 CubeSat and to make some measurements. And I will not speak about all the degree of autonomy that should have this mission, but here I'm more focused on the data. And really, colleagues in space exploration are developing tool and system, for example, to analyze the geometric shape of the asteroids, or the physical chemical composition of the surface. If there is some anomaly, there is an impact of a meteorite. Everything can be done really with technique of machine learning, computer vision, together with cloud computing and other novel technology. Now we move in telecom, is more or less the same things. Here is more in the design. When we decide a telecom system, we have the same application of AI, the same advantage: smart manufacturing, cutting cost, cutting the time between design, development, and testing, autonomous operation. But for example, different with Earth observation is that in this case, we don't measure, we provide a telecommunication service, and we have other problem, like optimization of the beam coverage, like in the picture here from a geostationary telecommunication satellite, or the managing of the resource in terms of bandwidth, or let's say mitigation of interferences due to the atmospheric effect of the interferences with other telecommunication or navigation satellites. And then, of course, yes, colleagues in telecom, they are developing tools and application to optimize this kind of resource and to mitigate any kind of anomaly. And then downstream to the telecom application, there are many. The colleague that's given me this contribution proposed so many applications. I just report a few of them, from safety, security, finance, food, agriculture, like we speak. All the application that can be built on a telecommunication system, basically, can really be boosted by the use of machine learning. And because of this, let me use this stage to make some advertisement for our telecom department about the new ARTES thematic call for digital transformation and green economy. It's a call that has been open in October and will close next year. There are several thematic channels: AI, digital twin, sustainability, mobility, green value. And this is an industry-driven proposal. That means you have to approach us and propose something, and then the proposal is reviewed. In this case, colleagues will indicate if it goes on and how to go it. So if you are really interested, please browse the website, apply, and if you need information, you can contact the name of my colleague that are in these slides. Now, we said We look internally also what we do, and especially with the knowledge management. We cannot hide that a lot of information is hidden in documents, in email, in technical notes. You can have the smartest repository that you want, but yeah, and colleagues in the department of Paris are really developing a using tool to use natural language processing to dig in this kind of a big amount of information and to make the knowledge more accessible when it's required. In my last slide, I will propose, like I said before, I propose few examples, but let's say this slide say where I'm working. I'm in the wave iteration propagation section. We are a cross multi-competence group, and what we do is basically we support especially Earth observation, navigation, and telecom project to understand what to measure when we build a satellite. So we do a lot of modeling and simulation, but also we support the project to create algorithm to post-process the data when it's acquired. And again, here the application of machine learning are multiple. This is an example of a project of my colleague about the estimation, the VTEC map on the atmosphere. So when the sun is particularly active, it can polarize some area of the atmosphere and create interference on the navigation telecommunications signal. And we know this is a well-known problem, and we monitoring through a network of ground stations in the world that they use also very complex algorithm to make a prediction. And in this activity, my colleague developed a neural net algorithm, very quick and very easy to use, that is trained with historical data and actually really can substitute the state-of-art algorithm in a more efficient way and can run in very even obsolete receivers. And this is a project that is I'm glad to say I'm managing, and I'm using two different technology at the same time, machine learning and then blockchain. The activity is concluded a few days ago, and we have prototype a system where a potential algorithm developer can train the machine learning algorithm the data is not stolen because the blockchain track everything. So through the smart contract, we train the algorithm, and then it's impossible to misuse or corrupt any other repository of test data set. And this is my last slide. I hope I've been clear, maybe too fast on presenting the application of AI, how we see strategically this technology, how we plan to engage the industry in several initiatives. But really the last sentence is the most important, because we really see that through this algorithm, we can really integrate the space data in the day-by-day application under the big concept of the big data, and using all this technology, not just machine learning, but like I said before, cloud computing. We really think this can bring space application closer to the ground and day-by-day application. And with this, I conclude. So I'm happy to answer all your questions.
Presentation, Riccardo.
Yes. Thanks so much, Riccardo, for this really interesting presentation. It was really interesting to see how important AI is in all your space applications for autonomous operations, for object recognitions on the rovers, for example, for the monitoring of the traffic, and especially to make all this data usable and to really dig into the data and make it accessible. Matthias, do we have some questions? Well, I think he's gone for a second. I'm sure he's gonna be back in any second. Yes.
All right. We have actually received a couple of questions on LinkedIn
Yes.
and YouTube. And for the first question that actually I would have is, you have so much data and repositories at ESA. For our companies and organizations in the AI sector watching right now, is there any possibility to kind of use that data? Do you have kind of a community that can um, join in developing certain solutions, or is there some way of engagement for people that would be interested in this?
Yes, of course. I can speak more extensively about Earth observation data. For example, on the Copernicus mission, we have what the so-called the scientific hubs, where you can just register. It's even for free, or if you need to do commercial service, you need to do the disclaimer. But Copernicus offer more free of charge data. You can even download the data. But there are other solutions like we are calling the DIAS solution, where you can the data is on the cloud, and then you can build your application on top. So without really moving the data, so you can build an application in the cloud. So there are multiple ways that you can access the data. Depend really of the data. If you, for example, we speak about navigation data, then you need to do. There are several other policies that need to apply it. But I think we is interested can really contact me or contact us, and depending, I can put really give them more accurate information.
Mm-hmm. I think you would need to put together a certain kind of call to action with the information that we presented in your slides, and with the links to that resources that you mentioned. And we will forward that through our channels to our
Sure.
viewers and listeners that have questions on that. Another question that we received is, Riccardo, what would you recommend to an organization that wants to bring their AI expertise to ESA, but has not done ESA projects before? The question is from Susanne Katzler-Fuchs of Brimatech,
Okay.
our
Yes,
cooperation partner.
there are many ways to do this. Generally, the most common way is to respond to our invitation to tenders. So there are public invitation to tenders of projects in a system called EMITS. Again, I can provide some information. The industry need to be registered in the system, and then they get, when there are projects available and founding, an invitation to tender. Not just AI, for all the ESA space projects. And this, you apply, basically, you submit a proposal, someone will review it, and if you are selected, you start working. Or, like I said before, there are unsolicited open calls, like in Artes, where you can approach us and you can propose something that is valid. I really encourage to see the Artes, what I propose here in the slide, because there are a lot of thematic channels. So industry can come to us, propose something, and we evaluate. And in case we provide the funding on, or some activity can be also need to be also co-founded. So there are many ways that you can approach us and to get found and to collaborate with us. Of course, there are also working group if you are more interested on the academy. For example, in for Earth observation and AI, there is the working group CLARE, that is basically linking together all the academy and a research institute in AI. They are regular meetings, so they exchange ideas about AI. So I really suggest to, I can provide more information in the next day about how to really apply to our project, or through an ITT, or through an open call. And there are many open call, also discovery, the GSTP element 2. There are many line of funding that an industry can approach us and propose their project.
So another question we have on YouTube is, do you have some news regarding DIAS situation in the near future?
Yeah,
and can you also elaborate what DIAS is?
Yeah, I mean, I think the user, it referred to a project like DIAS, Creo DIAS, where really there is an interface in the cloud computing with Earth observation. I think I'm not really managing directly this. There are more my colleague in exploitation that are in Esrin. I know that there are at least 5 or 6 DIAS access or DIAS services. CreoDIAS is one of them. To be honest, I need to get, I can contact, if the user contact me directly, I can put in contact with the technical officer of the DIAS. As far as I know, for example, in Blended that I used, I present in my slides, the data fetching was made by a DIAS service, so it was very active. So especially the CreoDIAS. And then I think this kind of DIAS is active and working properly.
Thank you very much. Well, Heinz, you should get in touch on LinkedIn, because that's where we have a working back channel. And thank you for your question. Florian, do we have time for 2 quick questions that we still have, or should we move on with the program?
We are a little bit behind. We're 6 minutes behind, so maybe let's make one.
One quick one, okay? What are the main challenges AI in space? Maybe a quick answer.
I mean, the AI in space is too challenging. One is the hardware, so the qualification of the hardware, so to develop chips that can embed AI, and this, colleagues are trying to move commercial like Movidius and NVIDIA chips, but of course there are plastic packages and they can melt with the radiation. So the qualification of the hardware is one of the two, and the second is the algorithm training. So how to train an algorithm to work in real time on measuring data. It's not like if you do the Coursera course in AI to recognize cat or non-cat in images. Here is a little bit more complex. So the generalization and the training of the algorithm on the raw data is quite a critical point. If there are other questions, I mean, I am available in LinkedIn to answer all of you. Or there is also my working email in LinkedIn. Really, I know that there are some other for me. I'm really happy at any time to contact me in case it's needed.
Thank you so much, Riccardo. Thanks a lot for your presentations. Let's move on to the next one, which is held by Christian Fidi by TTTech. Really happy to have him here. Christian Fidi, who started his career at the medical device company Ottobock, was key in developing TTTech's space product portfolio between 2015 and 2020, while the TTTech group was focusing heavily on the automotive market. In January 2020, he took on responsibility for the business unit TTTech Aerospace as general manager, and he looks forward to bringing software frameworks as advanced as the automotive domain to plenty of autonomous or semi-autonomous space applications like lunar landers, the Lunar Gateway, or future ISRU. And the title of his presentation is AI in Space, Real Enabler or Buzzword Only. Christian, really happy to have you here, and the floor is yours.
The floor is yours, and we already have your slides here. Talk to you in a few minutes. Post your questions and see you in the Q&A.
Thank you very much, Florian, for the introduction. So I would like to give you a little bit an overview of what our company is doing before I then go into the details about how AI is currently used in space. I'm just having, oh, sorry, that was too quick. To give you a little bit an overview of TTTech, so what is TTTech doing, and I think also why have we asked and where we are very happy to present here. So we are working in different fields of or in different verticals in mobility. So one is automotive, where we have released the first level 3 driving assistance system on the market together with Audi, where we have done the complete software integration. Then the field which I'm heading is aerospace and space. and we're also working in off-highway machinery, where AI is also very interesting currently, with all the autonomy coming to harvesting and other applications. And one big field is industrial IoT, connection to the cloud, and a lot of cloud computing, a lot of big data handling, as well as one field which we are also in is Android services. So Android services in set-top boxes, TVs, and so on. We are currently around 2,300 people headquartered in Vienna, but we have different locations, and you see below some of our customers and partners. So we are trying to keep a real big ecosystem of players. And to my agenda today, I want to reflect a little bit also based on what we have heard from Riccardo. How is AI in space today? What is the future bringing to us for AI in space? And what are the enablers? So what do we really need to have as a basis which allows us to do AI in space? So what do we see as the big market trends currently in the field where we are working? So one big field is for sure autonomy. And this we see currently on our streets, but also in air. So there is currently a lot of activities ongoing with autonomous driving, autonomous flying, urban air mobility, air taxis, and this is currently growing very heavily. So after a lot of years where we thought about it, so I think the first interactions we had in 1998, where we were talking about autonomous steering, autonomous braking in cars, and it took quite a long time until fly-by-wire became really state of the art. And now we are really moving into the next century, where we're really talking about completely autonomous driving, autonomous flying, air taxis. You see the drone market really getting up to speed. And this is one big field, what we see as a mega trend. And the mega trend continues by taking this autonomy, taking the data which is captured by the vehicles, but also by the different industries, and bringing that into the cloud. So connecting these different applications together and using the data and really make this data usable for a bigger audience. I think this is currently what we are seeing in the complete industry. We call it Internet of Things. Now it's called more and more cloud applications, cloud computing. And this is also one of the mega trends we see. And what we also see is what that brings together, especially when we talk about different kind of vehicles. We talk about safety and security. And this is for us the third big pillar of the mega trends, which is more safety, more security for this data, for the use of this data in the related applications. And this comes all together for sure with sustainability. So we currently hear a lot about green technologies. How can we ensure that all the activities we have on Earth make or ensure that this is sustainable, that we can really use that on a long term and also prevent certain pollution. So I wanted to quickly show you that before then I go into the AI topic. So what you see here is the complexity increase. And this is one of the things which is really for us, the groundbreaking part is how can we ensure safety? How can we ensure autonomy, autonomous applications based on data if the complexity increases by a huge amount? And I think there was a big paradigm shift when we went into autonomous driving, where people needed to go away from decisions based on sensor data, which is deterministic, predictable very easily, by going into predictions or decisions based on camera data, where different algorithms have to be behind. So you're going away from the old style safety, where you say, oh, I exactly know the states, I exactly can predict the states, and I use that to derive my function. into an area where I have a picture, where I have images, where I have video streams in very, very high resolutions. Same with radar data, same with laser data. And I take this information, and based on this information, I do decisions, and I do these decisions reliably. And how can I train my system that allows me to really be completely predictable and to trust the system and the applications? And what you see here is the increase of complexity in software. This is increasing and increasing, so it's really exponential. And when you look into a current state-of-the-art car, you really see that the number of lines of code, the number of software complexity is way higher than we had in any application before. And this is currently something which is really hard to be able to have deterministically, reliably, and ensure. And there needs to be different mechanisms on how to handle the release of these codes, the verification of these codes, the validation, and how to make it really predictable and usable in our daily life when we are, for example, driving a car. And this is currently what is driving us a lot, is how can we ensure that, and how can we handle that, and what are the mechanisms behind it. And this would not be possible with AI in general. And the big question is now, how can we apply these algorithms, these functions into space? What can we use there? And how is it also used, for example, in aviation, civil aviation, urban air mobility? There is a lot of different of mechanisms which can be reused from what we have now learned, for example, in the automotive industry, which is currently really pushing these applications to the limits, and is currently really bringing a lot for the other verticals. So let's look into AI in space today. So when we look into current spacecrafts, almost everything is operated remotely. Especially satellites are very, very much connected to the Earth and are operated remotely. Also, what we have heard before is if we correct the position of a satellite, a lot of it is handled remotely, and machine learning or AI is currently rarely used there. But there are operations where we cannot remotely control everything from the Earth, where we need autonomous operations. And there are some really good examples of autonomous operations. But for example, when we look into Mars rovers, the Curiosity robot is operated very, very much remotely, and is very, very slow. It's very, very so everything is very, very much planned, and it takes quite a lot of time to plan the trajectories, where to drive, what to do, and this is very slow and very remote controlled. Only when there are topics coming in like constellations of planets where it's not possible to remotely control, the people are rethinking and bring then in more autonomy. And now I think in future missions, it will be really the case that remote control is not possible. Imagine we are landing on Mars. So landing on Mars is not possible via remote control because the time difference of the data traveling between Mars and the Earth is too long. And for things like landing a spacecraft on Mars or doing operations there, which are more agile, which are more dynamic, it's not possible. So if we look into human spaceflight, currently what we see is that missions to the moon and beyond are requiring this kind of autonomous functions. And this will also be now really be adapted, and NASA and ESA and all the agencies are planning on how can we operate vehicles autonomously when they have safety critical features and the astronauts or the people on board are not able to do that within a certain reaction time. So essential maneuvers like docking and landing are currently already autonomous, but are they using AI? Not really. So they are really done very, very simple. And the topic is, will that be possible in the future to keep it that simple, because the different kind of maneuvers will use different kind of rendezvous in space and landing these rendezvous vehicles, and this will get a big challenge in the future. So when we look a little bit into Earth observation, I think we have heard that before, also from Riccardo already, what is going on there in Earth observation and the data which is coming from the Earth. I think what is also very, very interesting currently is satellite constellations. So there are satellite constellations upcoming, and these satellite constellations will be in the future used for real-time applications on Earth. So what is really needed there is that the communicate, or that these services, that these real-time services which come up will be used for communication, autonomous operations. So you have to imagine that in the future, when you are driving a car on the Earth in an area where you have no connectivity via telecommunication or via internet connections, then you will for sure need an infrastructure on which you can base this kind of functionality. Same for flying or maritime topics, so this will come up more and more. Also, what Riccardo already showed is we will need better forecasting, we will need better weather data, we will need better climate data to really predict on how the weather is behaving, how climate is changing. And there, I think a huge amount of data is already there. And I think ESA and the European industry is doing a great job in already getting climate data with all the satellites which are currently in operation. But this will extend, and there will be a new possibility of using data, using real-time data, processing it. Also in exploration for human spaceflight and robotics, autonomous operations on planets will happen. So what we currently see, and I will also show that later in one of the videos, is really there will be more people on planets. We are currently talking about bringing people back to the moon, bringing more robotic operations on the moon. There will be some moon infrastructure coming up, and this is currently, I think, well prepared on the roadmap. And then what is currently, I think, also very interesting is robotic missions to life extensions of satellites. I think what we have seen with companies like Northrop Grumman showing with MEV2, so with the life extension mission to a satellite, I think this is currently something which is really, really pushing the ground forward, and which will come in the future. So what I would like to talk now is, if we talk about real-time operations on the Earth, so what are prerequisites to ensure real-time applications supported by space on the Earth, and therefore we need deterministic communication. So what we currently see is there is a lot of increase in communication in bandwidth via laser comms, which is currently, I think, the state of the art, which will be applied to more and more satellites. So there will be satellite data arrays based on laser comms, which will provide low latency, low jitter communication, high bandwidth, and what is also needed is a synchronization between the different satellites, allowing really to deterministically have a communication between the satellites and between the satellite clusters. What is also needed there is, and this is also what Riccardo mentioned, I think very, very well, is the high performance compute. Yeah? So what we are currently missing is the hardware, so the high performance compute in space. So we are currently talking about CPUs in space, which have hundreds of megahertz, and which is not state of the art compared to what we currently have on ground. So it's really important that we push this barrier forward and that we really invest. What we also see from ESA, NASA, from the European Union, there are different calls out there really asking for high performance compute digital signal processing, GPUs, and this environment that's needed. And this is really something where we need to push that to the next level. And I think there also needs to be new architectures, new concepts where really compute, which is used on the ground, can be flown in space, and that we're really coming there in a performance level which really allows us to use new functionality, new software algorithms, new data processing on the spacecraft. So these data and this compute needs to be reliable and correct. And this is very, very tough if you have to think that you want to operate applications on ground, or you want to get data reliable and correct, and it's pre-processed in space. So we really need to ensure that not only the hardware, also our architectures are there, which allow us to have certain tolerance against faults in the system. And this is really something also that comes up with satellite constellation, which really brings a lot of benefit. And what is also important, I think, is currently what we see across the globe is really security. Security is getting more and more interested, and how can security, data security, can be built into the spacecrafts, into the data communications end to end. And this is something really important because we see a lot of cyber attacks on different in different areas, and this is really something where I think we need to work on, and which is really important. Autonomous vehicles operations. So since we are also working in automotive, as I showed you before, I think what is really interesting is how is automotive currently handling that, and how can space support it, and what can space do to support a safe operations of vehicles, be it cars, but also be it urban air mobility in the future on the Earth and in the air. And there, I think what we are currently seeing is that the cars currently on the streets are currently processing a huge amount of data. They are performing sensor fusion, they are doing decisions based on sensor data, and the processing is very, very demanding. It's very complex, as we have seen before in the software complexity, but it's also very demanding on the hardware. And the car itself is currently on the path to really get completely autonomous. But this will be extended by having in the future car-to-car communication, which really allows us to have a better situational awareness and get to a more reliable and safe operation. And the question is here now, how can space play a role there? And what we are currently seeing is that the communication, be it via using GPS, but also in the future, be it via satellite constellations, can really help us there to operate cars, but also urban air mobility, for example, very, very safely if we can use the space infrastructure. And there's currently a lot of things going on where we really see that this is interesting, but for that we need the low latency connectivity and synchronization, which we already have via GPS, but with the low latency connectivity, which allows to have different vehicles on the ground connected via satellites or via satellite infrastructure, that really helps a lot. And you can imagine that if we are able to get the data from the car up to the satellite, and this from multiple cars and from multiple urban air mobility vehicles, which allows us to really have the data on the satellite, and we could really use this data and perform different AI algorithms, allowing really to safely operate and to really also get a way better predictability of different kind of events. If a car has an accident, this data can be used. It can be provided to the satellite. It can be provided to the other cars, even in areas where there is no connectivity via Earth infrastructure. And this is really, really interesting. And I think this is currently one of the trends on which a lot of the new space companies are working on. Activities with the satellite constellation programs are really fostering that. So how does it look like? How can satellite constellations help us there? In the background, you see one of the activities where we are proud to be on board, UNIO, which is a program which we currently won, where it's really a push forward in bringing Europe into satellite constellations and really using this kind of functions and algorithms to really allow using the data highly efficiently. But what we will see with satellite constellations is that currently we see a lot of reduction on cost. So the satellites will get cheaper, the satellite operations will get cheaper, but also the access to space will get cheaper. So all the activities currently on small launchers, bringing satellites for constellations into space, bringing them safely there and reduce the costs of access to space, but also reducing the cost of satellites, because we are talking here about higher volume satellites. And these satellites will allow us in the future to really get high speed real-time communication, but will also allow us to get high quality data from these satellite constellations into our data network. And the big question is, what are we doing with that? And what you also see is like the program from NASA, so Cygnus. So these programs are also used, for example, reflections of GPS data to really, with a constellation, get very good quality, very good accuracy from different Earth data, and also the application or the discussion we had before with Riccardo showed us there is a lot of data available, and the question is now, how can we process this data? And we need here a high performance network and compute infrastructure which allows us to capture the data and to really be able to perform deep learning algorithms to process the data and to also process it maybe in a constellation, maybe in a distributed compute manner. What we currently see is quite interesting on Earth, but the question is, can we also achieve that in space? And what I would like to show you on the next slide, so this is where we are currently, so that shows what we are currently working on. So that's a picture from NASA from 2019 on the Artemis program. And what you see here is the connectivity and the demand on really having modular structures and allowing to use these modular structures, for example, to bring up different spacecrafts in space, to really let them rendezvous and dock, to let them operate different kind of mission scenarios while they are docked and while they are reconnected. And this infrastructure needs communication and needs data handling and compute to be very modular, to be able to transfer functions from one vehicle to the other. And there are different kind of new algorithms and new software, new applications needed to allow this rendezvous docking and then the related landing on the moon and then the moon infrastructure. This is I think very interesting, is how can we apply metals which we currently have on Earth for space to use it, for example, on the moon and then later onto Mars. And I think currently the plan from the agencies is very ambitious to really get that with international cooperations together. But I think this plan is really what is driving us, and I think what can really change the future. And I would like to close my presentation with providing you a short video, what we have put together on what we are currently doing there and how this is operating, and where you can also see that the data communication between the different spacecrafts and also then beyond onto the constellation is, I think, key, together with the compute allowing AI in space. And we will see in the near future quite a paradigm shift on how this is used and how this is done. I think we'll also get the hardware which is really capable of supporting the whole activity. So if we move to the next, which is then the video. Thank you.
Christian, thanks a lot for the great video and great presentation. Really fascinating how to see how AI is a necessity actually for all the autonomous operations, and how how space can benefit from the automotive industry and vice versa regarding algorithms, etc. As we are a little bit behind in time, but do we have, Matthias, do we have quick one or two questions?
We have a question. I cannot say it's quick, but maybe we can do a quick answer. Mr. Fidi, there's also CITS and 5G communication established or in the making. How can satellite communication improve vehicle safety? Can you give me some more details on this? So two possibilities. You can get in touch, or you can answer that quickly.
I think I'll do both. I think what is very important is that what I said, so in the future we will have car-to-car communication, but with what is currently developed with RF communication links between satellite constellations in LEO and on Earth, there will be in the future communications between car and satellites, and there will be satellite constellations which are forming a global low latency internet. And this means with the low latency capability, the data from each car can be connected to each other car. So this means in the future, if there is an accident, the cars around the car which has an accident will know that there was an accident. And the same is for other situational awareness, because the cars are capturing the data. And the big question will be, how is the data processed? What kind of this data will be connected to the satellites? What kind of data will be then distributed, and how will it be distributed? And I think to manage this kind of data, I think this will be the big challenge which will be upcoming. But this will be, I think, a big market which is really coming up, and which is very, very interesting for a lot of new startups. And we see that also already for the use of the big data from the car, but also from the civil aviation aircraft. Yeah. So how to get the data of the aircraft, what to do with it, how to maintain it, and I think the same will happen between or in our let's say infrastructure in mobility. Yeah.
Thank you so much. And if you're interested to learn more about TTTech, please get in touch via the LinkedIn networking option attached to our live stream there. Christian, Fidi, thank you so much.
Thank
we
you.
wish you all the best.
Thank you.
Thank you, Christian. And now let's move on to our next keynote, which is going to be presented by Clemens Wasner from AI Austria. Clemens is the CEO of Enlight AI, an Austrian startup specialized in applied reinforcement learning, as well as founder and chairperson of AI Austria, an independent think tank to promote AI and ensure Austria's competitiveness in that field. He's the organizer of the AAIC, the Applied AI Conference, one of Europe's largest conferences for applied AI, and an active member of the European AI Forum, a partnership of like-minded AI organizations which steer regulation in Europe. Before starting his own company, he spent more than 10 years in Japan and China, where he oversaw the Asia expansion as a partner in a managing consulting firm. Most recently, he was elected as the vice president of the ADRA, the Public-Private Partnership on AI, Data and Robotics of the European Commission. Wow, Clemens, welcome.
Thanks for the intro. It has a little bit of a Game of Thrones vibe, you know, where everybody has eight or 10 titles or more.
Exactly.
No,
which house are you in?
Oh, that's a secret.
Okay.
No, thanks a lot for having me today. Yeah, today is also a little bit of flipped roles because I will not be hosting the entire event, but I will provide a brief overview about AI in space. And yeah, coming a little bit from the AI angle, because lots of the use cases you have seen at the projects are like vice versa coming from space. So this is now basically ground control to space. So let me go to the next page. Yeah, good. This one, Florian just had very detailed. So I skip over this slide. I would like to start with why are we talking today about AI and what has happened in recent years? Because if you would have asked me 10 years ago if today we would make this type of event, I would have said, no, this is extremely unlikely that we will talk about AI in the first place, even more unlikely to have the combination together AI and space. So what has happened? And yeah, like most useful inventions in mankind, it can all be traced back to cat pictures. Because what you see here behind me is Andrew Ng. Back then in 2012, he was the leader of Google X. Google X, for those of you which are not familiar with it, they're like doing let's say, very far out progressive project, like contact lenses to trace your insulin level, or autonomous, back then also autonomous cars and so on. So one of his research projects in 2012 was to apply AI-based or the machine learning-based methods for image recognition on a very large data set taken from YouTube on cat videos. And the results were amazingly surprising because out of the gate, they reached almost 80% accuracy. I mean, of course, there was also lots of computing power involved. But nevertheless, it showed that deep learning, and in that case, convolutional neural networks have the possibility to really push image recognition forward. And this really was the defining moment, I would say, in the last decade, which kicked off an area of events. So the next big step was in 2016, when again from Google, this time through their research arm in the UK, AlphaGo, when AlphaGo beat the Go world champion Lee Sedol in I think in five games in a Go match. The interesting thing here is that many people expected this, yes, of course, to happen one day. Just think of what happened in 1997 between Deep Blue and Kasparov. What was the amazing thing here was that this happened 30 to 40 years earlier than anyone expected, because Go is a far more complex game. And in terms of decision making, the technology that is applied here, reinforcement learning, really moved the timeline 30 years forward, that an AI is outperforming the humans. So this, I would say, after these two events, investment went really into complete overdrive mode. And especially when it comes to the potentials of artificial intelligence, you will find lots of articles like this one. This is just like one out of many, which were envisioning a future where AI will contribute a huge amount to the total global economy, but also accelerate, let's say, GDP growth in certain countries by more than 3 percentage points. So very high expectations. And yeah, very unsurprisingly, this also led to the situation that many countries, not just companies, but countries, or let's say even on the EU level, formulated their own AI strategy. On the one hand side, regulation, obviously, but also very detailed specifications, how much money should be invested and for which reasons. And so this graphic that you see here is from 2020. Nowadays, there's almost no country that does not have an AI strategy, and the committed funding over several years, ranging from, let's say, $4 to $5 billion euros, like you have in Germany, up to $300 billion like you have in China. So this is really a gigantic movement. Why am I telling you all of this? The very interesting thing is that the recent interest in space happened almost in parallel. And I found this graphic quite striking. This is taking numbers from Crunchbase. So for those of you that are not familiar with Crunchbase, it's like the database product of the technology page TechCrunch. And they track venture funding across industries. So they have millions of data points. And it's very interesting to see that the uptake of space investments or space tech happened almost in parallel with AI technology. So the logical question now is, of course, how does AI and space get along, and why would you need AI and space in the first place, or the other way around? Coming from the space side, we heard in the previous talks already mentioned a couple of times what are the common limitations that you have when dealing with space. Yeah, so first and foremost is bandwidth. So be it L-band, be it any type of transmission, you will always have a bandwidth, let's say, limitation. The next one is compute. I think it was just in the talk from Mr. Fidi from TTTech, where he mentioned that in space you only have a couple of hundreds of megahertz. So we're not talking 56 core gigahertz there. So compute power is a big issue. And last but not least, the data quantity. So think of very large image processors, which produce hundreds of megapixel picture and this 60 times per second. So the data amounts are gigantic. So basically, if this is the space in, what is the yang coming from the AI side? And let's start first with compression, because if you want to solve bandwidth, compression might be the first area to look at. And here I would like to give you a brief introduction to one technology from the AI side. It's generative adversarial networks. Most of you might not have heard it, but I'm sure most of you heard other terms which are related to this technology. One of them is deepfakes, of course. The other one is the artificially generated celebrity faces and humans. So what you see here, this is when actually the whole boom with generative networks started. It was in 2017. This was released by NVIDIA, the chip maker, mostly graphic chips. And they trained here a system on 100,000 celebrity pictures, a GAN model, and the output was almost photorealistic. Nowadays, it's even much, much better. How does this whole thing works? You basically have two neural networks competing with each other. This is what the A stands for in generative adversarial networks. So you have one of them is trying to create a let's say as realistic or lifelike input as possible. And the discriminator is what I would say what the normal image recognition network is doing. It's saying looks like a real picture, or rather does not look like a real picture. And the output of the discriminator is like if the referee is fed in the generator, so over time it can improve the output, and the faces get, like you just seen on the previous page, get very realistic. What is very interesting here is when this started in 2017, this technology was something for the largest companies in the world. So when NVIDIA trained their models, they spent like $40 or $50 million on it, plus using their own hardware. So 2017, big money, tech corporation. If you look now on the right-hand side, this one is done by a startup that is based in California. And they offer to provide you, let's say, stock images with generated models or generated scenes. So with just within 4 years, coming from 2017 to 2021, this technology is now completely consumerized and usable. So it's not something in a lab that we might use in 10 years or 15 years down the road. It's already here. And just to show you where this technology is going, if money is absolutely not an issue, this is again the annual keynote of the CEO of NVIDIA, Mr. Jensen Huang. And yeah, the keynote goes on for, I think, almost 90 minutes. But what was amazing was they had a short segment where Mr. Huang was completely generated with a GAN network. And what you see here is this segment. And the striking thing is nobody realized this. NVIDIA said this 1 week after the conference, and even the tech journalists were saying, "What? Wow! Nobody noticed that there's a generated segment inside." So now you might ask, what does all of this has to do with compression? Basically, what happens here is that the generator learns the underlying structure of the pictures the discriminator is checking. You could say to a certain degree, this is a type of semantic compression that is going on here. And this is also one of the reasons why generative networks are not just here, let's say, to fake CEOs and make stock images, but they are also very prominently featured now when it comes to image compression. So this is an example where a research team at Google was using generative networks to upscale compressed images. Again, the left one is 64 times 64 pixels, and with the generative network, or let's say with the recompression or decompression from the generative network, it can be, let's say, enlarged to 1024 squared, which is insofar interesting as there are almost no artifacts. The same is true, even more important than cats. This is another example with burgers. It even works with a lower resolution for objects which are, let's say, following very, very different patterns. And so nowadays, you already have trials where this is also used on satellite data, this type of generative adversarial network compression. So what you see here is from a satellite, that is checking parking lots. And very good, I cannot see it because on my screen it's very small, but I'm sure in the live stream you can see that on the left-hand side, it looks like you have Lego cars, or let's say Duplo cars. It's very low resolution. Whereas on the right-hand side, it just looks like a photo of cars taken very far away. Here's another example where you can see it perhaps better. Again, the left one looks like, let's say, a VGA game from the 1990s, whereas the right one could also be if you fly very high in Microsoft Flight Simulator this year. So the potential is very large that you apply this nowadays in space, and especially, let's say, if you have to wait for the real data still to come in, that at least you could already send over a preview picture with a lower resolution, but which can be, let's say, enlarged with AI, and you can already do a first analysis there. So next, we had the topic of compute. Think of the few hundred megahertz, and that in general, the hardware that is used in space, this is up to Sun Spark level. So they're not the latest processor generations because they have to be especially error proof. What is interesting here is oh, the animation is not working. Yeah, doesn't matter. What I told you before with cat videos and image recognition, this was like in the 2012. It was in 2012, up to playing, let's say, Go with reinforcement learning, or playing any type of game with reinforcement learning, within just a very short time span, and this is covering 6 years, the compute power to train this type of AI models increased by a factor 300,000. And yeah, you don't need to be a mathematician to immediately understand that Moore's law is impossible to keep up with this, especially as the demand, or let's say the compute demand for future analytics, will increase even more. So what is currently one of the hottest topics in AI are specialized AI hardware accelerators, or AI silicon as they are often called, because they provide this type of speed up, which makes it even possible to, first of all, train models, and especially important coming now from the space side, to also deploy these, let's say, analytics models later in space with a very low power envelope. We talk here milliwatts to low watts here. This is far below, for example, a laptop or even a cell phone. How does the whole thing work? Good. If I explain this slide in detail, the rest of the event would be spent on this slide. But in a nutshell, everything that happens within an AI model, especially when it comes to analytics, is basically a very huge matrix multiplication. And if you now start with the left-hand side, classically GPUs and CPUs are not that suited for the task, because so what you see here in the register, let's say this is the data input. What then happens is this data input is going to the arithmetic logic unit. There it gets computed, and afterwards the result again gets written in the register, because this is, let's say, where the interim results are saved. And all of this has lots of computing overhead. What AI-specific chips are doing is basically in the matrix multiplication, when you have several layers, they have each layer in hardware. This means you start with the input, what is upper here register. Think of it, this is just on a pixel basis, the input from the image sensor from a parking lot, for example, or from a ship dock. What happens next is that the interim steps directly feed each other. So you calculate one weighing, and this goes to the next one and the next one and the next one. The speed up that you get here is in the magnitude of several thousands up to several tens of thousands cycles that you become faster. And additionally to being faster, you also become far more power efficient. And this is not science fiction. I think the colleague in the very beginning from the ESA, he briefly mentioned this one. In October last year, the first satellite with the AI module was launched into space. They're using from Intel the Mobius module, and so this one is already, let's say, up in the trial, and it's used for removing clouds from satellite images. And this is now handled to a large degree already directly on the satellite, so you don't need this back and forth anymore. The idea is to have also picking up the topic from the colleague from TTTech, to have swarm satellites in the future that do lots of this, let's say, edge computing already on the device and communicate with each other and then send the final result down. So this is a very extreme case, let's say, of compute and compression at the same time. So last but not least, one repeated topic that comes up when you talk about, let's say, satellite and space is that the data quantity is just gigantic, and it becomes even more, not just in spy planes, but in general communication and so on. And here AI analytics are actually a very good way to solve this, because for many different types of analytics, AI is already outperforming any other type of methodologies. So be it forecasting and time series analysis, be it computer vision, or finding, let's say, anomalies in data sets. This, for example, could be that you find anomalies in satellite-to-satellite communication, or a satellite to uplink. And just to give you one example how fast it happened in computer vision, what you see in this chart, this is like one of the standard visualization visuals to show that the progress that AI made in the last couple of years. At the beginning of the last decade, so exactly 10 years ago, the error rate of image recognition was 30%. This means that, in 70% of the cases, the output was correct, but in 30% it was incorrect. That's a little bit better than throwing a coin or rolling a dice. What's interesting or also striking here is that just between 2011 and 2016, it just was 5 short years that computer vision systems utilizing deep learning surpassed human performance. This is the red line that you see here. So what started with 30% was 5 years later below 5% error rate. And nowadays we talk here about, in most cases, less than 1% error that an AI-based system is creating. So long story short, what we saw here with computer vision will happen in many other places. And I would totally expect that this combination of compression, edge computing, and the general analytics performance of AI will make it the go-to solution for most applications, or let's say at least in tandem with other combinations. But it's safe to say you will see AI-based analytics almost everywhere. So yeah, outlook. Now comes the crystal ball. I already started a little bit with it. I think what is very interesting here is, I mean, of course, when you think of AI in space, the Star Wars droids come to your mind, or hell comes to your mind. This is not that friendly, but interestingly, there are currently, let's say, projects going on which really test how can robots and chatbots contribute to better work and operations at space stations. So the concrete project CIMON2, it's CIMON2. I can also post this later in the chat. This is really a robot that the ESA sent to space, and which is now in the 2nd generation. It will soon have the 3rd generation. And it's basically a free-floating robot, which is on the one hand side, we are interacting with the astronauts to let's say engage them and keep the concentration level higher, because studies show that if you all the time work alone, so your concentration will degrade. With this bot, you can raise it a little bit more. Plus, you have voice commands. I mean, of course, this is by far not hell level when it comes to let's say the intelligence behind it. But the interesting thing is that for many things where bots are or autonomous robots are just not feasible on Earth, mostly because of navigation problems. In space, this suddenly does not become an issue anymore. And I will also post later the link in the chat. This is a very interesting area. And yeah, I think this already brings me to the end of my talk. Yeah, if you want to get in touch, let's say with me or AI Austria, just connect on LinkedIn. And yeah, I'm looking forward to receive some your questions if there are any now.
Thank you so much, Clemens, for your presentation.
Thank you so much.
We actually received a comment from one of our previous speakers, Riccardo Ducca from ESA, and he pointed out to check out Microsoft Space Eye that is able to see through cloud cover. The link you see here, but also can click directly in the LinkedIn chat. Also a comment of mine. Yeah, I can't wait for the Applied AI Conference edition on gaming.
Who doesn't?
Who doesn't?
Yeah, but since Mr. Ducca posted the Microsoft example, we did the event. We had an Applied AI conference on forestry, timber, and wood industry in autumn last year. And one of the large-scale initiatives Microsoft has shown back then, I think it's called AI for Earth. And the topic here is that, for example, you use satellite data to check how global warming is affecting forests across the globe, or that you make something like a pre-warning or alarm system where it's very likely that wood fires will break out. And last but not least, that you also check, let's say, illegal harvesting, which is going on all across the globe, also in Europe. So it was quite interesting that the framing for Microsoft back then was out from the gate to do it over, let's say, satellites.
Mhm.
It was not like drones or cameras and smartphones, what you would have expected. And they, just to add to that point.
Just a quick question, Clemens. Where does the additional information that is added to the increased picture resolution with GAN comes from? It's a mysterious question with an exciting answer, I'm sure.
It's also a mysterious technology. Now, the way this is actually done is you start with the full resolution picture when you train the GAN, but additionally, you let's say, add a layer of noise to it. And throughout the training process, you reduce, let's say, the resolution of the picture more and more and more. At the same time, you increase the noise. So basically what the model is learning in this process is it learns how to let's say, in very simple terms, if it gets as an input now a noise level from a satellite camera and the very resolution again from a satellite camera, if it combines these two, due to this inverse training process, it learned how the original picture should look like.
So
thanks for listening to my TED talk. No, but if you're interested, hit me on LinkedIn. I can send you the link to the paper where this is described.
And there are already some repositories that you can try out for yourself if you have some basic knowledge in programming. Stefan, thank you for your question, and we will share that in the channel. So Clemens, that was it for that talk. Florian, we are a little bit behind in the program, but what can we expect further on?
Bye bye.
Bye bye. Thank you, Clemens. Our next speaker is Andreas Salentinig by the company Ubicube. And Andreas is the CEO of Ubicube, a startup that leverages space-related data, that is satellite imagery and POIs, to extract timely and accurate demographic and economic indicator maps to improve decision-making processes in business intelligence. The company is currently incubated in the ESA Business Incubation Center, Austria, managed by Science Park Graz. And the title of his presentation is Keeping an Eye on Human Settlements from Space. Andreas, hello, welcome. Please, the stage is yours.
Yeah, hello. Thanks a lot for these kind words and the introduction. You already said a lot. So, okay. My name is Andreas Salentinig, and I'm the CEO and founder of Ubicube Geospatial Solutions. That's the full name of the company. We are a Graz-based startup and the B2B provider of Earth monitoring services. And today I'm going to be talking about how we use space data, in our case, satellite imagery and points of interest, in order to develop services of real value for our customers. But first, let me start by introducing our team, as this is probably the most important factor for success. So we have Christian Oswald. He's an economic engineer, and he's responsible at Ubicube for the business development processes and also for the financials. Then we have myself. I have a background in Earth observation, and apart from general management tasks, I'm responsible at Ubicube for all the science behind our services and science related to the geodata. And then we have Benedict. He's our CTO, and he has a background in computer science, and he is also an expert in artificial intelligence, and he is in charge of the system architecture, the software architecture, and all the AI processes we deploy and implement. We have a couple of young talents helping us in developing the tools and also in doing the marketing. And currently we are incubated in the ESA Business Incubation Center, Austria, and they are supporting us, and we can make real progress through their support. But what do we do? So at Ubicube, we basically use space data and artificial intelligence in order to develop monitoring services. And with space data, we mean satellite imagery and, of course, also points of interest. We put them into so-called geodata cubes, and that's the base for our machine learning that's sitting on top. And then from there, we operate in different fields. So for instance, we just recently deployed a surface water monitoring service that our client is using for biodiversity research and also as a base for compensation payments for flooding events. Then we are also operating, like we are monitoring buildings, how they evolve. We're doing like construction site monitoring using satellite imagery. And also we are using the whole satellite data archive in order to predict trends in urban sprawl. And then there's another topic we are working on, also in a research project funded by FFG here in Austria. It's about people living in cities, so about economic and demographic indicators. Yeah, so this is our whole setup. We are mainly serving customers in the real estate and construction sectors. And today I'm going to be talking mostly about the economic and demographic indicators, because I think that's the most innovative approach we are working on at the moment. And also we see a big potential in that field. Okay, so but as an introduction, so we are all on the same page, prepared a couple of examples, what we mean with socioeconomic and demographic data. It's basically maps, high resolution maps of different indicators. So for instance, we have population density or the net household income or a demographic indicator like average age. And of course, the list can be a lot longer with those indicators. And this information is really important to a lot of different applications, starting from retail, when you're looking for a new store location or a location of a vending machine. And then there are a couple of other applications when it comes to, real estate investment or even disaster response. So the list is also here really long for people or applications that are interested in having this kind of information. Of course, up to now, there are methods to generate this kind of information, to compile the data. So the most traditional one is, of course, having a census, a national census. Here, of course, it's not updated frequently, so there's a time gap in between. Then another possibility would be to use surveys. They are usually kind of local and not, really cumbersome to do, and also therefore they cannot be repeated every day or every couple of days or whatsoever. And then more modern approaches use, for instance, mobile location data. Here we have some problems with, the accuracy of the actual location of the people, and also the data is not available everywhere. So in some countries you can actually get the data, in others it's not possible. And the last approach that's currently also being used to derive economic and demographic information is social media, of course, and more specifically geotagged social media posts. So you gotta have like a location to your posts. And here the problem is that this geotagging behavior on the global scale is not fully understood. So in some areas, a lot of geotagging is going on. In some other areas, there is almost nothing going on with geotagging. So also here, it's kind of hard, I guess, to develop scalable global products. And we at Ubicube, we are working on a solution to some of these problems. Actually, first I have to tell you what the problems are with that. So based on the state of the art of the methodologies, of course, there are some problems to data quality, so then data availability. So in some areas, as I said before, they're not available everywhere, so it's hard to compare. And also the comparability is limited. So you have different resolutions, different timestamps, so it's hard to compare over time and also over beyond international borders. So at Ubicube, we are working on a solution to some of these problems. And we are using geodata, satellite imagery and points of interest, as you know it from Google Maps, for instance, or OpenStreetMap, in order to estimate economic and demographic indicators. And you probably wonder now, like, how on earth is that possible to do that? And let me start my explanation showing you a picture of a Starbucks coffee shop. So everybody knows Starbucks. Not so many people are familiar with the so-called Starbucks effect. It's a phenomenon that pretty much states that the closer a property, like a flat, an apartment, is to a Starbucks coffee shop, the higher the rent prices will be. So here we have really a relationship, a positive correlation, and it really makes sense. So our system that we are designing is basically looking for relationships like these, to looking for correlations in order to estimate the economic and demographic indicators. So we're using, as I said already a couple of times, geodata, satellite imagery from different sensors. So we're using radar imagery and also optical, and points of interests from known sources, and derive so-called geofeatures, which are stored in data cubes. And geofeatures are, for instance, the vegetation fraction in some areas, or the density of buildings that we can derive from satellite imagery. And then other geofeatures derived from points of interest would be the density of restaurants, or maybe for some areas, the dominant restaurant type. So all this information is stored, again, as I said before, in the data cube. So here we have then for each point in a certain area, hundreds of different features and information. And this is, of course, the perfect base for some machine learning in order to estimate whatever you want to try. And here, of course, you have to provide to the system a reference data set showing some spatial patterns of a specific indicator. And yeah, here are the machine learning is on top of all of that. And basically here, the idea is the system is using, in this case, a deep neural network in order to find relationships like the Starbucks effect, and to figure out which are the most important predictors from the geofeatures in order to mimic the spatial patterns from the reference data. And so already here you have the advantage that you can find out, okay, what are the most important factors, the driving factors actually, driving the spatial patterns as they are. And the really cool thing is then once this model is trained, you can convert this knowledge and the model to other areas and estimate the same indicators, but on different areas. Our clients can get access to this whole framework and system. The idea is to have it like a software as a service, where you can actually bring in your own data and do an analysis with that, and feed it into the system in addition to our already existing data cubes. And the first step, that's what we're actually working on at the moment, is a data as a service, where you can go to a web platform, specify an area of interest, and then download the data of the indicator you desire, you want to have. So pretty much like an online web store for socioeconomic and demographic data. Yeah, so for this data warehouse, we implemented the first data showroom, where you actually see how the product will look like when it's done, or the service will look like. So this whole process, as I said before, it's still under development. It's a research project funded by FFG here in Austria and the European Space Agency. But you can, with this URL, you can access actually our showroom and see how it works. So you basically specify a date and the area of interest, and then what kind of parameters or indicators you want to estimate. Yeah, feel free to check it out. Yeah, so this is basically what we do with the economic and demographic indicator estimation. And usually at this point, I show a slide summing up what I just said before in order to make sure that everybody gets the main message. But today is different. Today, instead, I'm gonna show you a video, a brand new video of an explanation video for this whole economic and demographic indicator estimation. So you're about to witness a world premiere, kind of, because like apart from us, the Ubicube team and the guys making the video, nobody has seen that. So lean back and enjoy our explainer video.
Finding the optimal location for, let's say, a store, a bank branch, or a vending machine is a challenge, as many socio-economic, demographic, and other factors have to be considered. This process becomes even more difficult when you have to gather data from different sources and deal with problems arising from comparing varying methodologies, or even a total lack of data for specific regions. Existing solutions try to overcome these problems by harmonizing national census data, local survey results, and other statistical data. But this still leads to an unsatisfying outcome, especially when you want to compare data over a longer period of time or beyond international borders. In order to tackle these problems, Ubicube developed a unique and fresh approach to provide you with globally available, high-resolution economic and demographic data based on a unified scientific methodology. To estimate the mean household income, for example, Ubicube uses information derived from state-of-the-art satellite imagery and remote sensing, like private building density or garden size, and combines this with geotagged information from hundreds of other sources like dominant restaurant types or traffic volume. All these types of data are then fused together in Ubicube's unique geospatial intelligence to map the corresponding indicator at an unprecedented level of detail. Ubicube, crunching geodata to boost your business.
Okay, so all right, so the last slide I prepared here is about our challenges, like from a startup perspective with space data and AI. So basically, one challenge is, of course, the technology itself. So processing power and storage. I mean, these problems are becoming less important, I would say, or less apparent due to cloud computing and everything. So we are, of course, as a startup, trying to move all our processes to the cloud. So we are ready to actually process this huge data volume. Also, the access to space data is kind of a challenge, but also here we have really good progress. Companies actually doing all the work, all the pre-processing, and you providing the data, the analysis ready data. You kind of need to develop solutions. Then also, what's a big point for us, at least with the models, we always try to make solutions that are globally applicable. And this transferability of our models is sometimes a problem. So if you think about what I just explained before about this economic and demographic indicators, I mean, of course, if you train a model with reference data from Vienna, it won't be applicable on the whole planet. So you kind of have to have a strategy for different models doing the same thing, but for other geographic areas. And then, of course, on top, and this is actually, from my point of view, way more challenging, is the business development itself. So satellite imagery and AI, the potential is just enormous. There's so many use cases you can think of. Like every time I talk with somebody, what we're doing, like almost everyone has, can you do that? Can you do that? And the thing is, maybe it's too many choices of what to do. And it's kind of hard to find a niche. It takes some time. You have to talk to a lot of people. So this is really challenging, at least for us as a young and fresh startup. Also, I mean, sometimes it's hard to, of course, we want to have scalable solutions and services, but until you get there, you are kind of the project business. So it's kind of, you have to be careful not to be a project company. I mean, I'm not saying that this is bad, but if you're a startup, you want to have, of course, scalable solutions. And the last point I want to mention here is that awareness is missing, I would say, in general. So if you talk to people about satellite imagery and AI, like most people would say, okay, cool, so you know how to use Google Maps. And so for most people, satellite imagery is Google Maps. And we also witnessed that in our talks in the last couple of months. So there is not too much awareness, and especially in combination with AI. I mean, a lot of people, I would say, have this, I don't know, Terminator pictures in their head with artificial intelligence. So they are kind of, don't want to get too close. That, I mean, I'm just reporting our experiences. So, and the combination with space data and AI sounds like maybe too futuristic for some people. Yeah, but this is basically the main challenges for us as a startup. But of course, also like for this kid, the future is bright, and I'm more than sure that there will be a lot of companies also coming out of this space data and AI, and the potential is just enormous. Okay, one last challenge we are facing, I want to mention here, is the challenge of finding good talents and young people actually motivated to work in that field. So currently we are growing our team, and we are looking for a geospatial data scientist and a machine learning engineer. So in case you're interested, or you know somebody who might be interested, just drop us a line at office@ubicube.eu. Or, I mean, this is of course also valid if you just want to get in touch to exchange ideas for collaborations. We are more than happy to talk to you. Thanks a lot.
Thank you so much, Andreas, for this exciting presentation, and also for sharing the world premiere of your video with us. We have, in fact, received a couple of questions. Let's have a look at YouTube. Here, Stefan asks, do you face any problems with correlation versus causality in this AI application? And he asked this question early on in your presentation.
Yeah, thanks, Stefan, for this really interesting question. And yeah, that's basically the point of our main challenges. Problems, correlation versus causality. So yeah, long story, like as we are progressed timely a bit, it's a big thing, yeah, and we are doing a lot of tests to see what kind of indicators we can actually estimate. And yeah, there's still a lot of work to do, but yeah, it's research, so we are still positive, of course, that we can shape this whole project, and that there's actual value in it. Yeah.
Thank you so much, Andreas. And Andreas is also available in the networking on LinkedIn, so feel free to get in touch. Thank you very much, and best wishes.
Thank you, Andreas. Also from my side, great approach, great solution, great video. Also, I didn't know about the Starbucks effect, and it's great how you incorporate all this kind of information into valuable information for your customers. Great. Thank you.
Cool. Thanks.
As we are, we completed our keynote block already, the first block. And thanks to all the keynote speakers for the great presentations. And now we will have a look on how to actually accelerate those technologies. And we do this by introducing funding and support opportunities. And we will have the first presentations, or the first out of 4. By one of our colleagues, Susanne Kassler-Fuchs by Brimatech, and she will talk about the Space Hubs Network project, the ESA technology transfer, and ESA. Welcome and hello.
Hello, Florian. Hello, Matthias. Thank you for the introduction.
I would say that the stage is yours. We have already prepared your slides, I think. Let me just bring them up. No, I don't see your slides right now. So if you care for
I will
sharing
try
them
to
again.
share them.
Mm-hmm. Otherwise, Florian, maybe you can give us some information while we... now we have the slides
Perfect.
here. And
Super.
there you go.
Okay, thank you. So, hello from my side as well. My name is Susanne Katzler-Fuchs. I work for Brimatech, and I would now like to show you how we can support your space adventure. In the previous presentations, we heard a lot of ideas, how space can benefit from artificial intelligence and the other way around. And now I would like to show you how you can realize your projects in space or in AI and a combination of both. Basically, I have 3 offers for you and 3 ways how we can support your space adventures. So the first offer is the Sun project. The second offer is the technology transfer from space to Earth or the other way around. And the third option is to do ESA projects. The first option, the Sun, is a project that's a Horizon 2020, a large European project with a lot of partners, a lot of knowledgeable partners across Europe, as you can see here. And basically what we do in this project is we support startups in their project or in their way to getting a space startup. We do that by supporting the pre-incubation, the pre-acceleration, and also the post-acceleration phase. And we have a really large pool of highly experienced and knowledgeable mentors that are ready to help you with your ideas. The other thing that we do is we are doing hackathons, as for example, the AI for Earth Challenge hackathon that we just had this autumn. But we are also doing roadshows and online events such as this one here today. But also, for example, we had an Mechatronics Meet Space event in spring this year. So what we basically try to do here is we are bringing together space with application areas on Earth, try to find synergies and try to find new communities that can join our space projects. If you want to find out more, you can either go online to spacehubs.network, or you can, of course, contact me. The second way or the second option that I would like to show you is the technology transfer option. So Brimatech has been technology transfer broker for the European Space Agency in Austria for more than 10 years now. What we do is we identify space technologies and find application areas for them on Earth, or the other way around. So we do spin in and spin out, and we bring together different application areas. Again, we bring together space with interesting options on Earth and try to find synergies here. So if you think that you have a space technology that has a super nice application maybe on Earth, or you have a very interesting technology that you think has a potential in space, please let me know and we can find out together. We are not doing this alone here in Austria, of course. We are embedded in a broad European network that is funded by the European Space Agency. It's the ESA Space Solutions Network, consisting of a row of national partners that do technology brokerage, that host the ESA business incubation centers, and that are ambassadors for ESA around Europe. And the third option I would like to show you very quickly is how you can do business with ESA. It has also been touched briefly by Riccardo already in his presentation earlier. If you want to do business with ESA, the first thing you really have to do is you have to register yourself at ESA Star. And if you register yourself at ESA Star, you have access to ESA Star publication, where all ESA tenders are published, and you have access to ESA Match, where you can find all registered space organizations around Europe, and can also present yourself there. Some words to ESA Star publication. There's a screenshot here for you. You can find all tenders that ESA wishes to publish in the future, so the intended tenders. You can find all tenders that are open now with the deadlines attached, and you can also find tenders where already negotiation phases are going on. Of course, you can search in these tenders, you can set your preferences, and you can also have an automatic email notification when tenders pop up that might be interesting for you. If you're thinking about doing business with ESA, or if you want to join this, do this, please get in contact with me or with the Austrian Aeronautics and Space Agency. We are always here to help and support you, because in the beginning this can be quite a challenge and maybe also complex to dive into this ESA world. And the second thing I wanted to show you, when you have registered with ESA, as I said, you can be part of ESA's industry matchmaking portal. It's ESA Match, where you can find other entities doing business with ESA, where you can find what they are doing, what their expertise is, and you can also find partners for a potential ESA project that you would want to apply for. That was it very, very shortly from my side. The basic message is, if you want to get support in funding your projects in space, please contact me and I will try to help you, try to direct you to the right contacts and the right sources. Thanks.
Great, Susanne, thank you so much. Just a quick note, we will do the Q&A after the 4 blocks after the 4 presentations. So thanks a lot, Susanne, for your presentations, and we're gonna move on. I'm really happy to welcome Ines Placido from Science Park Graz, and she will talk about the ESA Business Incubation Center Austria. Hello.
Hello, good morning.
Good morning.
Can you hear me well?
Yes, we hear you very well.
Perfectly. So I will then share my presentation with you. Sorry.
You look so much like Christmas already in your background.
Ah, yes, it's the spirit. It's already here. Can you see my slides already?
Yes, it's good.
Perfect. So my name is Ines Placido, and I'm the ESA Space Solutions Austria Manager at Science Park Graz. And I will introduce you today to ESA Big Austria as a support program for business ideas, which, for instance, may link AI and space. As a quick introduction, Science Park is the largest and oldest business incubator operating in Austria since 2016. And we were entrusted then by the European Space Agency and the Austrian Aeronautics and Space Agency to implement the ESA Business Incubation Program in Austria. The ESA BIC in Austria is one of the 22 incubation centers of ESA, which forms the biggest space startup network worldwide. In this network, more than 1,200 startups have been supported in more than 60 locations across Europe. And most importantly, what can you get from the ESA BIC program? Well, the program offers a grant of €50,000 for startups, no equity taken in the company, which can be used for the development of the prototype of the product or service, or to deal with intellectual property rights. So this could be about protecting your invention or accessing technology from third parties, for instance, from ESA or the space industry. The incubatees also have the great opportunity of using the ESA BIC logo in their presentations and communication, as you saw with Ubicube, which definitely works as a sort of a seal of credibility, which is, of course, critical for small companies when approaching new customers, partners, and investors. By joining the network, the startups have access to space and non-space partners, let's say from academia, from industry, and they have access to special deals for startups with some work tools, for instance. They also have exclusive opportunities to pitch and to showcase their solutions in Austria and abroad. And of course, the program supports startups accessing space data, systems, patents, and knowledge to integrate in their current or new business ideas. A team of consultants is also ready to accompany each startup in their business and technical challenges and to help them leaping forward. ISABIC Austria, so let's say in practice now, selects twice a year and incubates 12 new startups every year for a period between 1 to 2 years. We look for teams and existing companies up to 5 years old, which have what we call the space connection. The space connection can be twofold to make it simple, upstream and downstream. With upstream, we mean those companies which target space as a market, for instance, that develop satellite components, propulsion systems, new space exploration concepts, new business models in space, and so on and so forth. With downstream, we mean those companies that find in space a source of technology, IP, knowledge, etc., which they can use in their products and services for other markets, so terrestrial markets such as mobility, health, environmental protection, and so on. With downstream, we also mean those companies using satellite navigation like Galileo and EGNOS, communication, or using data and imagery collected by satellites. Because the topic of today has to do with AI in space, I brought you today a couple of examples from our portfolio of startups, which illustrates the variety of use cases where both domains meet. So AlphaEdge's software leverages sources like satellite and meteorologic data to provide, with the support of AI algorithms, strategic insights for energy management, asset management, and for risk and insurance stakeholders. In the case of RT, they develop AI kits for autonomous mobile robots charged with transportation tasks. The idea is to enable these robots to navigate in forests, in rescue missions, in alpine areas, or for outdoor transport. DLTO is an AI-run and peer-to-peer and crowdsourced platform for satellite data mining and trading. And then Ubicube, which you have already heard about earlier today. So should you be interested to apply or have any questions, do not hesitate to contact us. Thank you very much.
Thank you very much, Ines, for your presentation, for the intro on ESA Space Solutions Austria and Science Park Graz. One question is, you have kind of a for startups that would be interested in getting to know your network, a kind of a community event that they could join, or what should they do? Just send you a message, or do you have something?
Exactly. Yeah, we're very active on social media, so this could be one entry point. Of course, we have our website, and we organize some community events from time to time. I'm sure 2022 will be one of those years where we'll push this extra further. So open to the community or by invitation after a small initial chat. So we're always open to initial conversations. Yeah.
Great, great. And we'll also share your slides and some additional info in the post-show notes, so to say, with everybody registered on our streams and on the mailing list. Florian.
Thank you so much. And thank you for the opportunity to present.
Thank you. Yes, thank you, Ines. Up next is Elisabeth Klaffenböck from the FFG, the Austrian Research and Promotion Agency. And she will talk about national and international R&D funding, like the ASAP program or Horizon Europe. Welcome, hello.
Yes,
Hello
do
and
you
welcome.
hear? Welcome, hello to everyone. So thank you for the introduction as well. So my name is Elisabeth Klaffenbeck and I am from the FFG, the Austrian Research Promotion Agency. And I'm working in the department for space here. So we are a small department, just focusing on space. And of course, I talk about national and international funding, but in this case, focused on space. So now I have to check if I can, yes. Perfect. So I will focus on two elements. The first is the national funding program, already mentioned. And the second one is the Horizon Europe. So in my presentation, I will focus on these two. First, the Austrian Space Applications Program. So this is, as mentioned, a national funding program. And I'm really sorry, this is my only slide in German language. But I think the main message is very clear. So this is a national funding program focusing on three elements. One is science, one is technology development, and the third is applications based on space infrastructure. Why we are doing this national funding program? So the main focus is the leverage effect of this program. We try to make our actors in Austria fit and mature for first, and this was the core idea 20 years or close to 20 years ago, fit for ESA programs. Today, it's not only ESA programs, it's in addition EU programs. So 20 years ago, EU did not focus on space, but you are aware that in the meantime, EU very much concentrates on space. Then we have EUMETSAT, which is also a focus for us. And of course, the commercial market. But this is out of our hand. But if someone goes from ASAP to the commercial market, this is super fine for us, and especially for downstream and applications. This very often is the case, and I think AE is more relevant in the downstream sector, so this could also be a possibility. Just some rough numbers about our space program. So as mentioned, it's running since 2002. We injected roughly 120 million euro in this program and funded since 2002 more than 750 projects. I don't want to go into the details on the goals and topics, so you will receive the slides. But I would like to mention one thing. This is in the right corner on the bottom, or in the box at the bottom. It's the first line. It's digital twin. So what we try to implement for Austria is a digital twin, and I think for this topic, AI could be really an added value. So just to give you this information, the funding rates are between 35% and 85%, but for small companies, the 85% are applicable. What's important is that my colleague Daniel Jokovic, he was not able to present today, but he is responsible for managing this program. So if you have any further questions or you need details, please contact him. And now I remember that I forgot one important thing. Unfortunately, the last call, it was the 18th call, closed 1st of December. So the next possibility will be next September, October timeframe. But you should, of course, remember that you have this possibility. The next point is the Horizon Europe program. I don't know if you are familiar with this program. This is a very would say, complex program, but it's running 7 years. This is always the financial time frame for European programs, and close to 100 billion euros are invested. And I think this is a tremendous amount. And you have different pillars, different, how do you say, sub-programs. And you should be aware that under pillar 2, you see it in the middle of this graph, you have the space topics reflected. So this is important for you. Within this cluster 4, within this pillar, you have several clusters. And within these clusters, you have different destinations. So you can forget all these things. For you, important is that destination 5, space, is included. And what I want to show you is the main focus, I would say, for these space activities is the evolution and the development of space infrastructure. So the financing for the space infrastructure is another budget line, but here all the developments and pre-developments are included in this Horizon 2020. So you have a lot of activities where I think this is more upstream, as Ines explained. So this is upstream, but you see in red, you in addition have development of applications for Galileo and EGNOS, which are the European navigation systems, and Copernicus, which is the European Earth observation system. So I think this could be very interesting for you. So I provide you with some links. Of course, I will not go into detail. And what I have in addition included in the presentation as annex, some slides with more details, but I think it's too much now. What's the funding rates and things like that. So I included that in the annex you will receive. Maybe one comment on all the rules and things like that. The competitive success rate in this program is rather low compared, for example, to our national program. So where you have very good chance if you apply to get funded. Here the average success rate is about 15%. Austria usually in the space sector is slightly higher, but 15 to 20% still very competitive. So I want to give you that information, as I think it's important if you plan to prepare an application. In the FFG, my colleague Hans Rohowitz is responsible for space in the European Union programs. So if you need anything, please contact Hans Rohowitz, who was also not possible to present today, but he's very, very informed and usually very supportive. So please contact Hans for any further information. And of course, so I did not prepare a slide for that, and I think it's not necessary, as Ines and Susanne mentioned very often ESA. So of course ESA is already today and planning much more in the future, focusing on AI. So I think with the information you received from Ines and Susanne, and especially the ESA star, where you get all the information, I think you have enough information for today, but if you need any additional information, you can contact Susanne or me. So we both deal with this ESA context. So this was it from my side. Thank you. And as promised, so you get the more details with the presentation.
Thank you, Elisabeth. Thanks a lot. I think it's always important to promote these offerings, these different funding opportunities for the people who are not so familiar with it. Thanks a lot. Up next, we have Georg Sedelbauer from the Wirtschaftsagentur Wien, that is the Vienna Business Agency, and he will talk about regional funding. Hello.
Hello, everybody. Thank you, Florian. Could you put up my slides? My name is Georg Sedelbauer. I work for the Vienna Business Agency. That's the regional business promotion agency of the city of Vienna. I work in the department Technology Services. The Vienna Business Agency offers various kinds of services for companies in Vienna. So our focus is companies in Vienna. This includes also funding, consultation services, workshops, coaching for startups, also assistance if you look for industrial space or office premises, and we also facilitate contacts to potential partners. In our department, Technology Service, our job is to connect technology developers in Vienna and foster collaboration and research in Vienna. We do not have many activities dedicated to space technology, but of course it fits in different programs. Today I will present two services. So we start with funding. Vienna Business Agency offers also funding programs for companies, mostly companies based in Vienna. We have a research funding program that's always a thematic call. The next call will start in spring 2022. The topic will be zero emission city. This means energy, mobility, circular economy, infrastructure. And of course, this might be also a field where space data, space technology, and of course AI might be relevant. It's open for SMEs, but also large companies, and research organizations can be partners. The funding rate is between 25 and 60% for companies and 80% for research organizations. Another program, I just picked the four most relevant programs. The portfolio is quite broad. Another program that is also not so well known, but I think it can be very useful. It's about initiating R&D collaborations. So if you are a company in Vienna and want to establish a research and development collaboration, this will help you to finance those activities. In practice, it's often used to creating a project proposal for a EU call. So what you just saw at FFG, this might be a good tool to finance these activities before submitting a proposal, finding the partners, defining the way of collaboration with the partners. It's also used for drafting proposals for complex FFG calls like COMET projects or COMET centers. The funding rate there is quite high, it's 75%, and the maximum funding amount is 30,000 euros. The next program is the program Innovation. That's our classic. That's open for all topics. It's just for SMEs. In that it's about developing innovative new products or services. And the last program I want to present is for tapping into new international markets. So once you have developed the product, the technology, and you want to go abroad and access a new market, this will also help you. The funding rate there is 50%. Funding amount is up to 50,000 euros. So the takeaway message here is Vienna Business Agency offers funding programs. Check out the website or contact me if you're not sure which program is suitable. And for everybody who is active in drafting EU projects and is based in Vienna, definitely check out this program R&D collaboration. So that's the part about our funding programs. The different service we are offering is the Co-Creation Lab Vienna. Within this framework, we offer expert workshops. So if you have specific questions, we organize a workshop, we plan the workshop design, we organize workshop facilitation, and we invite suitable experts. This question can be a very technical one, or it could be related to a new business model you're working on. And our USP is that we have a really broad network of over 5,000 experts in almost any field. So we can support you with regarding almost every question. So if you want to have more information on our co-creation lab, I also put the link in the slides. But of course, feel free to contact me on LinkedIn or call me or email. Thank you very much.
Thanks a lot, Georg. And now we have some time for some questions. Matthias,
Right.
did some questions arise?
And I would like to get everybody back on stage. Let's see, we have Susanne Katzler-Fuchs, and unfortunately Ines already left the chat, but we had already cleared one question with her in advance. So one question, let me just quickly pull it up. Thank you very much for an excellent overview of funding opportunities, which is indeed essential to co-finance and support the Austrian European research and development. So this was also a thank you message for all of you, including Ms. Klaffenböck and Ms. Placido. Those two had to leave to other appointments, but thank you very much for your comment. We will share the info on our channels, including the presentations. If you're interested in getting in touch, I'd invite you to do so. Good. Well, Florian, do you have anything that you want to highlight among the mentioned opportunities for startups and other organizations that want to set foot into the space sector? Well, or rephrase something.
I think we offered a wide spectrum of what is possible, and in the keynotes, and how to actually put foot on the ground for startups or any entrepreneurs actually. So from the idea phase to a really really advanced stage, there are many opportunities, and I think everyone has an overview over this now and should make use of it now. So no more remarks from my side.
Well, one thing that I would be curious to know is how would a company that has absolutely no previous experience in the space sector, like no contact points with ESA, with NASA, nothing, go about finding out if their products or services are of interest to collaboration partners in the space industry? Did you have cases like this? Question to Brimatech.
Yes, maybe I can answer this question. This is quite a common case. So people come to us and say, okay, I have this wonderful technology and I think it would be really beneficial to bring it to space. But how can I do this? And this is where we help. So there are different ways of doing this, but usually we try to bring them together with ESA for a first meeting to see whether this is really a technology that ESA thinks is interesting. And then there is other opportunities. ESA also has a portal called Open Space Innovation Platform, where you can submit your ideas or your technology ideas very easily, and ESA experts evaluate them for you. So if this is the case, please contact us and I'm sure we can help.
Thanks. And again, as a reminder for the startups that we're watching, the call for startups is open until December 21, so not much time left, but still open, and you can check it out on the spacehubs.network.
Exactly, thank you.
And now we have prepared something really special, and I think your colleague Stephanie Brenner will explain how this next agenda point will work, because now we open you the possibility to do one-to-one networking with other participants. Let me get her on stage. Stephanie, hello.
Hi.
Stephanie and Florian, can you share a little bit about how the networking will work in this next coming couple of minutes?
Yes, sure. I'm happy to do that. Will you share the slides, or shall I share the screen?
Oh, I will bring up your slides.
Okay, thank you. Because we've prepared some slides just to give you a brief introduction into how to use this interactive networking tool. So first of all, just follow the registration link that will be posted into the YouTube and into the LinkedIn chat.
Can we post that now?
I'm sorry?
Can we post the link now?
Yes.
Florian?
I guess so, yeah.
Mm-hmm.
Okay, then we click on the registration link.
Yeah, just click on the link, and then you're asked to take a photo of yourself. If you're not happy with it, you can retake it. And then you're asked to enter your name. Please enter first the name of your organization, and then your last name, and then your first name, so that everybody knows who is in this networking room. And then just some more information about the most important functions, especially how to move in this room. If the registration was successful, you will enter the room that was created for the AI Meets Space event. The background will look a little bit different, but still the functions are the same. So you will see your own avatar, which is your picture you have taken. And to move in this room, you just have to click your left mouse, hold it, and move the mouse through the space. And so your avatar will also move through this room. It's very intuitive. If you which is only visible for you, so that you know where exactly in the room is this person at the moment. And you
Right.
can also use the chat function for talking to everybody in Wonder and also to just the people within your circle. Yeah, so
right.
enjoy the networking and have some
I think we have to try that out.
Yeah.
Yes.
It's very intuitive. So
yeah, so not much
Okay.
explanation needed. There is the links. We posted them on the YouTube channel and on LinkedIn because they're a little bit clunky, and we are not AIs. We are just eyes, and they are hard to remember. So we posted them on LinkedIn. Just head in the chat window, or on YouTube in the chat window, click on it, and from then on, it's pretty intuitive. You will also join the networking right now. So we wrap this up. Applied AI Conference and Space Hub Networks presented AI Meets Space. Thank you to all participants. And Florian, for a wrap up.
Thank you so much for participating in these times where there are so many online events out there. We are really, really happy that we had so many participants today. I think we had a really nice program, great keynotes and great funding opportunities, presentations that we presented. And lastly, please use also the networking opportunity right now in Wonder. And thank you to everyone who participated to this event.
Have a good day. Bye-bye.
Bye-bye to everyone.